plot, hopefully, what they are, where everything is, and how everything, which one is more sensitive, this sort of thing, as a general. Now, an equally important one from the Evans website is this plot, is the pro-depth, if you like, is the pro-depth of various techniques. Like, how service sensitive are these techniques, right? That's the question. Let me see if I can go there. Oops. So here we listed the common technique of how the service sensitivity that you got. And so typically you have, so here's the answer to the earlier question, what is a surface, right? It depends on your perspective. So here we have the top layer that Aaron said, usually 3 nanometer, physically around 3 nanometer or so, and then 10 nanometer is called the near surface, and so 3 nanometer, roughly about 6 smaller layer, okay, roughly something like this. And so that's all the action is, and usually it's covered by oxide. So you have to remove all the oxide, and then you get to the real part of the surface like this. And then if you are talking about thin film that you put thin film on, is about 10 to 100 nanometers. And then if you're talking about coating, this is just jargon. It's a thicker thin film. That's a coating. Microns, usually around microns length. And then way down is bulk. So I would say once you go below near surface is bulk, because if the layer spacing don't change anymore, you have reached the bulk region. We'll talk more about how we define a surface a little bit later on. But this is the different technique, how surface sensitive they are. You can see atomic force microscope, we'll see why in a few lectures when we talk about atomic force microscope. Why is it so surface sensitive? And same goal for scanning tunneling microscopy as well. I add the same because it's based on very similar principle. Electron emission from the surface. Here is due to force interaction of the surface atom. So that's why you are really Armstrong sensitivity. And then SIMS, time of flight SIMS, depending on how fast your ion beam is etching your surface, sputtering your surface. You can think of the ion beam, you're sandblasting the surface with iron, and depending on how gentle you use this sandblasting, you can remove your layer very slowly, and so you could be very surface sensitive. You could remove one layer at a time, and you could do it very surface sensitive. XPS, X-ray for electron spectroscopy. OJ electron spectroscopy, similar technique. We'll talk quite a bit about this. Is usually 2 to 3 nanometers, right? So it's very surface sensitive as well, okay? And then XRF, right? X-ray fluorescent spectroscopy, right? Look at the fluorescent signal from here, usually a few nanometers. Service SIMS is a different type of SIMS. RBS, which is Rutherford backscattering. Not many people do this anymore because it's a very uncommon technique, not a very lab-based technique. So, but Evans still does it for people for some type of material. So we won't talk too much about Rutherford backscattering. It's involving just scattering of neutron beam from your surface from there. And then of course all the chemistry is standard tool, FTIR, X-ray fluorescent, Raman, SIMS. You know, it could be sensitive all the way down to the bulk. You know, because it involves sputtering that you got. Okay, so the thing that I want to impress you from this plot is that different technique can probe different part of your surface, all the way from surface to bulk, right? And the most surface sensitive technique is STM and AFM. Okay, so that's something to key to remember. And your generic technique that you see in the common chemistry lab spectroscopy, FTIR spectroscopy, is usually good for the bulk because they are not, because all the signal can come from the surface and also come from the bulk. So it's not so useful in terms of surface the signal from the surface. Okay, whereas XPS, for example, will be quite useful. It's mostly come from the surface. That this is sort of the depth, right? How much interaction volume that you will see, the information depth that you get from these techniques. Okay, so quite useful, and if you also go to the Allen website, it gives you a little bit more detail. So I just want to flash this one. People